Okay guys, today we are going to look at how to solve by completing the square. This is a review of Algebra 2. You learned that you could solve these are quadratics that we're talking about. You can solve a quadratic a couple ways. You can graph, which nobody really likes to do. You can factor. You can use the quadratic formula, which we talked about. Or you can complete the square. And when we start talking about conics, which we're going to be talking about very, very soon, conics, to put them in standard form, you have to use this completing the square process. So today we're just going to practice completing the square. So we're going to start with this basic quadratic, x squared minus 2x minus 24 equals 0. So the first thing is, it always has to equal 0. Okay? Always has to equal 0 before you start completing the square. Well, technically it doesn't, but I like to set them equal to 0. Then what you do is you move the constant to the other side. X squared minus 2x equals 24. And what you do is you make a perfect square trinomial. This is the square part. So what you have to do is, in Algebra 2 you learned you took b divided by 2 squared. So you take half the middle term, so half of negative 2. So negative 2 divided by 2 is 1. 1 squared is 1. So now I change this to x squared minus 2x plus 1. If I add 1 to this side, because that's all I did, I have to add 1 to the other side. So now, on this side I have 25, and this side I have a perfect squared trinomial. And what I have to do is I have to make that into one binomial squared. So what times what gives me x squared? X. And what times what gives me 1? 1. This is a minus, this is a plus, so this is subtracting. And now, since there's nothing in front of here, you can solve for x. To get rid of a square, you have to take the square root. So I'm going to take the square root of both sides. So on the left side I have x minus 1, and on the right side I have plus or minus 5. Okay, so then my answers are x equals 1 plus or minus 5, just solving. So 1 plus 5 is 6, 1 minus 5 is negative 4. Those are my two solutions. Which would mean, if you graph this parabola, let's say here's 6, here's negative 4, it probably looks something like that. Okay, let's try one more that's just a little bit harder. 3g squared minus 12g equals 4. Well, I told you I like everything to equal 0, but on completing the square, the constant needs to be over here anyway, so I'm just going to leave the constant there. So now what I have to do is I have to complete the square, but before I can do that, I need to get this variable by itself. I need to get rid of the 3, so I have to factor what's ever in front of that squared variable. So 3, if I take 3 out, I have g squared minus 4g, because I have to take 3 out of both things on that side, equals 4. Right, here comes my completing the square part. I'm going to take half of negative 4, which is negative 2. Negative 2 squared is 4, so I'm going to add 4. Now this is the tricky part that students forget. Over here, remember I have to do the same thing on both sides. And a lot of students would tell me I'm going to add 4 right here, but I'm not. I actually have to add 4 times 3 because I'm multiplying 3 times everything inside this parenthesis, so I actually have to add 12 here. So now I have 3 times g squared minus 4g plus 4 equals 16. So then I have 3 times g minus 2 squared when I factor, because factors of 4 are 2 and it's a minus, equals 16. In this problem, what you have to do before you take the square root is you have to divide by 3 first, because you want this term, the squared term, by itself. So you have g minus 2 squared equals 16 thirds. And now you can take the square root. So I get g minus 2 equals plus or minus the square root of 16 thirds. So my answer is going to be g equals 2 plus or minus the square root of 16 thirds, which I know is probably not a great answer, but I'm going to leave it like that for the video. When you take your quiz over this, there could either be decimals there, or they might just leave it written like that. And those are both your answers. They're real answers because there's no I, so they are real answers. That's it.